कनेक्ट हो गया कनेक्ट
Hi, am I audible?
Hi, Somdeep.
Hi.
Good that you could register.
Yeah, sorry. I mean, I didn't realize that I had to register before, so I.
Yeah, no. So they had a link where you were supposed to register, but then it was removed. I don't know the technicalities. So
Okay.
you were not supposed to register, but I don't
I
know
see.
why you had to. But anyway, hello, Dilip Sinha ji. I'm glad that you could make it today. Yeah, I can see your
Slides are.
Yeah, and you're also quite audible.
Okay, that's good. Just see. So the
Good
slides are
afternoon,
moving,
sir.
Ashmita?
Yeah, they are moving. I can see
Great.
them.
Great.
Good afternoon, Sanjay ji. We can just test your
Yes,
audio.
Ashmita, good to see you.
Yeah, great. Your audio sounds perfect. Sudha. Hello. Hello, Sudhanshu. Can you just test your audio?
Yeah, good afternoon. So am I
Hi.
audible? Yes.
Yeah. I hope I am audible also.
Yes, sure.
So still have, I think it's 3, so we'll just start. Yeah. So Somdeep, are we good to go? I'll just formally start are you ready?
Sure, please go ahead.
Yeah. So welcome everyone for joining in today. And it's a pleasure to have Dr. Somdeep Chatterjee today, assistant professor at IIM Lucknow. He's going to present his work on the effect of electrification on children's education attainment. I think this is not only a very, very interesting paper academically, but it is also so I just request all the speakers once to mute yourself, all the participants to keep themselves muted unless you are talking. And if you have any questions, please raise your hand or type your questions in the chat box. Uh, and meanwhile, please keep yourself muted in order to prevent all sorts of background noise. So I was just talking about today's lecture. It is talking about a very, very interesting issue, which is not only important from the point of view of a research perspective, but I think it has immense potential from a policy perspective as well. And particularly with the COVID situation that we see around us, I think this issue of electrification becomes even more important. Access to electricity becomes even more important. And I think one of the most devastating effects of COVID would be on education. And a lot of people who do not have access to, say, technology or are not, I'm not, Surajji, why don't you mute all? I don't know why there's so much of background noise. Uh, yeah. So I think particularly in the COVID situation, this aspect is even more important because access to electricity, access to technology, it will be a determining factor, not only um, on your education attainment levels, but also what quality of education that you receive. So I think we'll hear today's speaker first, and then I'm also hoping that one of the uh, one of the aims of this seminar series is to bring together policymakers and researchers together in a platform and to come up with ways in which one can think about how policy making can be better improved given the circumstances and how research can provide that feedback for better policy making. So I'm looking forward to a very, very interesting discussion today. Let me just quickly, uh, yeah. So let me just quickly introduce our panel today, panel of speakers today. We have Shomdeep, who is, uh, as you must have all seen in the poster, he is an assistant professor at the Indian Institute of I'm so sorry, Indian Institute of Management, Lucknow. And he has done his PhD from Houston. We had a few years of overlap together, and I'm lucky to have known some of his work ever since. He has been doing excellent work, primarily in empirical micro. And along with that, we have Professor Sudhanshu Kumar. He is an associate professor at Center for Economic Policy and Public Finance at ADRI. He he is he primarily works in econometrics and public finance related issues. And today he's going to discuss Somdeep's paper and provide his valuable insights. Along with them, we have a very senior policymaker with us, Mr. Sanjay Kumar, who is the Additional Chief Secretary, Education Department, Government of Bihar. He is a senior civil servant at the Government of India and having more than 30 years of experience in Indian administrative services. He's currently the Additional Chief Secretary in Education Department, but before that he was in Health and other departments as well. And he has done his BSc in physics from St. Stephen's College and MSc from State University of New York. So I'm hoping that after our presentation, Sanjay ji would have some important policy insights for the speaker, and I look forward to an interesting discussion. So how do we proceed? So first, I think this would be a pretty useful way to go ahead with today's lecture. First, Somdeep will present his lecture, and then we have this discussion by Sudhanshu for about 5 minutes, and we take up questions for discussion if there are any, and then we then Mr. Kumar would give his uh, comments on the presentation and what policy insights can be had. Unfortunately, Professor Ghosh could not make it for today's meeting as he had some other urgent appointment to look into. So he is not present with us, but I'm glad that all of us are here, and I'm looking forward to a rather interesting session. So over to you, Somdeep, now. Please begin your presentation now.
Great. Thank you. Thank you, Ashmita, and thank you everyone for joining in today. And thanks a lot for the very kind introduction. And it's really good to see you after many years. So, reminiscing some of the memories of grad school days. Anyway, so this, as you can see, it's like joint work with, two doctoral students, right? So one is currently at Binghamton University, and the other one is at IIM Lucknow, which is Jai Kamal. And I think he perhaps would have joined this seminar as well. All right, so without further delay, let me quickly get into the premise. So I don't know why my slides are stuck for some reason. Yeah. So again, so the premise is that infrastructure development in mostly rural areas of developing countries, and particularly for India, which is the context of this study, has been a very important strategy for economic development. Right now, there has been a literature in economics which kind of focuses on the effects of power and energy sector on industrialization, and then eventual increases in productivity and so on. For instance, the Sustainable Development Goal of the United Nations, which is something that has been doing the rounds for quite a while now, for the last decade or so, I believe. One of these major objectives of these Sustainable Development Goals was that you need to provide access to modern and clean energy sources to everybody by the year 2030, right? So consequently, after this was announced, a lot of developing economies have sort of ambitiously revised their universal electrification programs. I would not go to the extent to say that they have come up with very new programs per se. A lot of them have, but in general, these have already been in place. But generally they have been kind of uplifted, or focus has been increased and so on. So there is a huge body of literature in the domain of economics, particularly energy economics, which talks about the positive effects of access to electricity on a host of outcomes. So for instance, access to electricity leads to better GDP, leads to better household income, has better health outcomes, and it has potential labor market consequences, so on and so forth. So there's a host of empirical micro literature which sort of predicts this. In this paper, however, what we are interested in is to understand whether access to electricity affects education outcomes. But are we the first one to actually look at them? Are we the first one to actually think about this? Not necessarily. There have been some papers which have looked at education outcomes as well. So I'll tell you why our context is different or unique, and why we still think we are able to make some sort of incremental contribution to the literature. So the major problem is that the empirical evidence that exists is that there is access to electricity on the one hand, and it leads to some kind of educational improvements, but there's largely mixed evidence on this. So some studies find that it leads to higher attainment levels, such as Lipscomb, Mubarak, and Barham, Kumar, and Ronier, and so on. However, other papers suggest, and generally that there's no convincing causal estimate on achievement levels. So while you can talk about it has led to increases in enrollment, it has led to lesser dropout rates and so on, but not necessarily actual learning. There has been some recent attempts by SEO which find that there are no impacts on learning, and otherwise there are some other counterintuitive kind of perverse consequences where people find that this is actually worsened education outcomes. So for instance, the idea is once you provide electricity, maybe they're watching more TV, or they're spending time elsewhere and not studying. So that has had perverse consequences. So these have been potential concerns in general. But in general, the idea, given there's a large literature, as I said, is that in terms of human capital investments, at least, there is considerable evidence. So like electricity access is thought of to be pretty good. So in this paper, what we are doing is estimating the effect of access to electricity on test scores of children, right? So we actually use test score data to measure learning achievement levels, and we use some kind of village fixed effects, time fixed effects specifications And because we are concerned, so again, these are some of the technicalities. So this paper has two sides to it. One is the policy story, as Ashmita was pointing out. The other is the empirical methodology story, which is trying to get at the causal inference. And we do a host of those things to try and attempt to make sure that what we are estimating is actually causal and not just a correlation. So in order to achieve this, what we do is use three alternative identification strategies as well. One of them is to use a 2SLS, which is an instrumental variables estimation. The other one is to do matching based on propensity scores. And finally, we use a quasi-experimental variation from a policy which was implemented in the state of West Bengal. So these are three alternative strategies, apart from the main regression. What is heartening for us is that using all these three strategies plus our main strategy, the results are the same. So irrespective of what we do in terms of the methodology, the results that we come out with are eventually predicting whatever we predict, right? So it's very consistent in that sense. Now, of course, we know that each of these methodologies have their own problems. Like if you talk about IV, you might be worried about exclusion restriction. If you talk about propensity score matching, you might be worried about matching on observables and so on. But nonetheless, since the idea is that all of these give the same result, we are reasonably confident that we are picking up something which is worth considering. And in doing so, we are using two different data sets as well. One is the India Human Development Survey, which is widely used, and also ESSER, which is Annual Status Education. So just a brief preview of results. What do we find? We find that there is strong positive impact of electricity access on academic performance of children. That means the test scores are improving. And we find that these effects are mediated through substitution in household time use patterns. Like, on the reduced form kind of story, it makes sense that, okay, you provide access to electricity, test scores are going up. But why is it happening? It's happening because of time use patterns. That now they're spending more time doing homework at home. Now they're spending less time, for other things that they would have been doing in the counterfactual. So this is the story. And of course, when I get there, I'll talk about the channels in more detail. Oh, sorry. Okay. In terms of the contribution to the literature, again, to the best of our knowledge, this seems to be the first empirical evidence of a positive impact of electricity access on test scores of children in a causal setting, right? So that's the incremental contribution we are trying to bring to the table here. Okay, now you might be wondering that what is so special about this context, right? Because on the one hand, you're saying that you find a positive effect of test scores of electricity access, right? But you're saying that in the literature, people have tried this in the past, but they have not been successful. So what is it that is different in our case that makes us come out with this story that, there seems to be some effect? The main and the primary reason that we could ascertain is that our focus is on household and village level electrification, as opposed to the host of studies that have been done on school level electrification, right? Now, there's a significant difference between the two. Why? Because if you don't find effects of school level electrification on learning, you could potentially say this is because of inelasticities of learning with respect to such infrastructure, right? So even if you improve the school infrastructure, that does not necessarily translate into learning, right? Now, again, those of you who are familiar with the literature on economics of education would know that there's a major concept of complementarity of inputs, right? So essentially what we are saying is that it's not enough that you just enhance certain school level inputs unless the complementary inputs are also going up at home. So what this program does, or what our study does actually, is essentially study household level electrification. So when household electrification is there, naturally your household level inputs seem to improve. So you can leverage those complementarities. So that could be one potential reason why test scores are effective. There could be another potential reason. The other potential reason being that, how much does it matter whether you have electricity in the school or not, right? Because in general, it's not that we are digitally very advanced, at least in the pre-COVID world, right? So you're not digitally advanced. So the incremental or the marginal value that electrification at the school brings is sort of minimal, right? So it's just like you probably have light, but anyway, you have a lot of daylight, and a lot of the schools, those of you who have visited rural schools would see that, they're studying out in the open, in the fields. So it doesn't really matter whether you have electricity or not in terms of your learning ability. But what matters is if you have electricity at the home, now you don't have darkness. So potentially you can study. So potentially you can supplement by studying at home. Potentially, you can do your homework, so on and so forth. And that is likely to enhance your learning ability, and hence you find some kind of result. So that's the basic difference between existing studies and our study. All right, I've already talked about this, and just to give you some more context, and I'm pretty sure a lot of you already know this, that India is generally characterized by high enrollment, like almost 95% enrollment that we have achieved. Now, on paper, that sounds awesome. Then it's great that you have 95% enrollment, but less than 50% can actually do basic reading and arithmetic tasks. So we are not being able to translate academic participation into academic performance, right? So maybe you can think of these types of interventions, or like infrastructure interventions where you provide electricity and other basic services at the home level, potentially having spillovers that can help translate this into academic performance, right? So when governments are actually sitting down and kind of figuring out whether a policy works or not, and what are the impacts that we are assessing of this policy, what are the costs and the benefits of the policy, what our paper does is to kind of give you that insight that potentially you should also think of the spillovers. When you're thinking of electricity access, when you're deciding whether or not to put out electricity or invest in electricity infrastructure, you're just thinking of electrification in general. But there are spillovers on the other sectors, such as education, which you also should be accounting for. So that's one of the policy highlights that is coming out of this paper. All right, so now I'll go and dive deep into the actual estimation. So the main data set for this analysis is the IHDS India Human Development Survey, and we use both the rounds 1 as well as round 2. We have over 42,000, it's close to 42,000 households spread over majority of India. And generally, it's like a nationally representative data set. However, the data for standardized test scores is only available for 8 to 11-year-olds. So we kind of have to restrict the sample to households which have 8 to 11-year-old kids at that point. And these are some of the basic statistics that you can see. Reading test scores ranges from 0 to 4, math test scores range from 0 to 3, and writing test scores range from 0 to 2. So of course, because I'll show you what are the specific characterizations. So if there is an individual who cannot read at all, that person gets a score of 0 on reading. Can read just letters, gets 1, can read words, gets 2, and so on. And similarly, these indices are there for math as well as writing. But again, since the ranges are not necessarily comparable, to make it comparable and also to get the estimates to be of meaning, at least in terms of what the sizes mean, what we do is we standardize all these test scores further. So we'll be reporting all the results in standard deviation units, right? Okay, so I'll show you the quick regression framework first, and then we'll talk about alternate strategies as well. So essentially, this is the outcome variable that we are interested in. That means the test score of child I, right, in neighborhood or village J, in household J, in village V at time T, right? So this is the main outcome variable that we're interested in. And this is the dummy variable, which is whether this particular household has electricity or not. Right? Now, this could be household electricity or village electricity, depending on what specification we are running. But it will be taking the value 1 if you do have access to electricity, and 0 if you don't. Now, of course, there are potential concerns about endogeneity. Like you can think that having electricity, the households that do have electricity are potentially very different from the ones that do not have electricity, and hence test scores are likely to be confounded. The estimates of test scores are likely to be confounded, which is why we do a host of other controls. Right? So we put in a lot of household controls, such as highest education level, number of children, family size, so on and so forth, age, gender, individual level controls as well. And additionally, we control for time fixed effects, as well as village or neighborhood level fixed effects. Right? So this is more or less a strategy. The identification assumption here is that conditional on these fixed effects and conditional on these observed characteristics, this beta 1 should be capturing the effect of having electricity access on your test score. Now, despite all of these controls and despite the fact that we have these fixed effects, you still may be worried that there could be other concerns, and that is precisely the reason why we do a host of other strategies as well. But nonetheless, for now, let's go with this idea that beta 1 is going to be the parameter of interest, which is capturing the effect of having access to electricity on test score. So let me quickly show you some results based on this ID strategy, right? So in panel A, I am reporting results from for reading test scores, panel B, math test scores, and panel C, writing test scores. The difference, because I have, the reason I have 4 columns is, I tinker around with the fixed effects. So in the first column, I have no fixed effects put in, no controls put in. And the last column, I have all the fixed effects as well as all the control variables put in. And it doesn't really change the story much. So this is, of course, our most preferred specification, which has all the controls as well as all the fixed effects that we think are relevant. So the interpretation would be, it's like providing, if you have access to electricity, then your reading test score is likely to be higher by 0.25 standard deviations, right? So that's the idea here. Similarly, if you have access to electricity, your math test score is likely to be higher by 0.2 standard deviations. And if you have access to electricity, your writing score is likely to be higher by 0.16 standard deviations. Okay. So potential mechanisms. In terms of potential mechanisms, the first thing that we look at is household income. So you can see household income is again positive and significant, which suggests that households that do have access to electricity have higher income, right? Now, there could be a selection story going on as well, but nonetheless, you see that this is indicative of that, household income is higher. And as a result, in general, well-off households have better resources that they divert towards their kids' education, and hence test scores are higher. In terms of fuel collection, these are time, right? Fuel collection time is measured in minutes, although it does not seem to be statistically significant because the standard errors sort of blow up because we're clustering at the village level. So you can understand that it's very large standard deviations, standard errors, sorry. But I think point estimate suggests that fuel collection time is actually going down if you have access to electricity. And that makes sense because, if you're having access to electricity, then you spend less time collecting fuel. What do you do with that time? So you're substituting that time towards, studying at home and so on. So this seems like a plausible channel, although statistically we aren't able to do much, but nonetheless, if you just purely go by anecdotal evidence, this seems interesting. Okay, in terms of time spent on studies, because if this is going down, if your time spent on collecting fuel is going down, it must be going up somewhere, right? Where is it going up? It's going up in terms of your homework, time spent doing homework. It's going up in terms of your time spent doing private tutoring. So that tells you potentially that, maybe you're spending less time outside and spending more time towards, things that are going to lead to having higher test scores. So that's a plausible channel. The first column you can think of sort of a placebo. Having electricity at a household should not actually affect your time spent in school. Why? Because you're going to school anyway. It doesn't really matter. And we find that it's basically a zero. So that's sort of reassuring in some sense that you're not picking up some spurious relationship. It is actually a meaningful relationship. Okay. Okay. So the rest of the paper is less about policy implications, but more about trying to convince you that the story that we are trying to put forth is actually meaningful and believable, and it's something that you should really take cognizance of, right? So I'm going to show you a host of alternate identification strategies. Most of this I can actually skip because you know what I'm talking about. So I'll jump essentially to one strategy, which is propensity score matching. So what we do is we match the households with access to electricity to a group of households without access to electricity. But of course, as I said, these households are different. So you cannot attribute difference in test scores only to the fact that a group has access to electricity and the other group does not. So what you ideally want is that these groups should be very identical, very similar otherwise. The only difference being that one group has access and the other group does not have access. Because then if we compare the test scores of these two groups, we can say it is potentially due to access to electricity. So we use the Rosenbaum and Rubin 1983 approximation method, which is sort of an approximate random assignment using matching based on propensity scores. So it's like figuring out the households that do have access to electricity. And from among the households that do not have access to electricity, we want a group which closely mimics this treated group. That means sort of a clone group, right? So we are matching on observables and we're estimating the predicted values based on all these observed variables that we have. And then when we compare the difference, we find that it is still 0.3 standard deviation or 0.25 standard deviations roughly. So the point estimate is a little bit different from what we had initially, but it's still not starkly different, and it's still telling you the same story nonetheless. So that kind of is convincing in a way that indeed electricity access is leading to better test scores across the board, no matter what test score you're considering. So that's one alternate ID. And of course, in the paper we do, and I'm not showing you all these graphs because there are various things that you need to check for when you're running propensity score matches, that these should be having common overlap, there should be a sufficient reduction in standardized bias, all these technicalities we do perform. If any of you is interested, I can go back and show these to you at some other point. All right. So the second strategy, the other alternate strategy, is an instrumental variables estimation, right? So what we do here is use the village level electrification as an instrument for access. So what we're claiming is that, whether or not you have access to electricity is sort of endogenous, because, you could potentially decide whether or not to sign up, whether or not to fill out those forms, whether or not to pay your bills on time, and so on and so forth. But whether your village has access to electricity in general is sort of a supply side decision, and it's less of a demand side decision. So if we use the supply side decision as a proxy or an instrument for your choice of whether you have access to electricity or not, then maybe some of these biases can be taken care of. So that's the backdrop of the idea of having an IV estimation. So this is known as 2SLS, where 2SLS stands for two-stage least squares. So what we do here in the first stage is we estimate, we use has electricity, that dummy variable, as the dependent, and run it on the village level electrification rate. That means whether the village has, like, what proportion of the village actually has been covered in terms of having universal access to electricity. And then we get these predicted values, which we call has electricity hat. And then we use this in the second stage, which is now we have our main outcome variable test score, and then run it on the predicted values. Then potentially we're using this village electrification rate as a proxy or an instrument for this particular variable, right? Now, there are two critical assumptions that are there in any IV estimation. The first is the relevance of the instrument, whether the instrument is relevant or not. In econometric terms or in technical terms, it is that the has electricity dummy must be strongly correlated with village level electrification rates. And of course, this is fairly rational, right? You're only likely to have electricity if your village has electricity in the first place. If your village is not connected to the grid, then how else would you have access to electricity? It's very difficult, right? So that's thing number one. So that checks the box. The second assumption is about instrument validity, which is sometimes in econometric terms known as validity of the exclusion restriction, right? So that is untestable. So you cannot test it. It's sort of an assumption, and all you can do is kind of hope that people who believe you, people who see your paper would actually believe those assumptions, right? So the assumption here is that village level electrification affects test scores only through access to your electricity, right? This is something that either you believe or you don't, but it's really hard to think of other channels, right? It's hard to think of a channel why village level electrification would affect your test scores other than through the fact that you are directly able to use this electricity for your own purposes. So we are sort of confident that this exclusion restriction should hold. And there are a ton of papers in the literature which actually use this type of instrumental variable. So it's not that we are coming up with a new innovation here. We're just using the standard practice, and reassuringly, we find that the results are the same. So it's again in the range of 0.23, 2.4 standard deviations, right? So it's not different in terms of the results. Okay, right. And the final alternate strategy that we do, we call it a case study, because this is not a national study any longer, but this is just a case study from the state of West Bengal, where the state of West Bengal in 2012 came up with a program which was colloquially known as Shobar Ghare Alo, right? So it's like providing electricity to every household. Their aim was to achieve universal rural electrification within a 2-year time span, right? So this was the program that was launched in 2012, and the idea was that 11 disadvantaged districts of the state. So they would select 11 disadvantaged districts of the state, and 100% household electrification would have to be achieved in 2 years. So this was the program. And they targeted around 28,000 villages. So this would reach out to almost close to 4 million households in these villages, right? As of 2016, as per UNDP reports and the reports that have come in, except 72 villages, most of these villages were at least connected to the grid. So that's like almost close to 100% electrification was achieved. Now, why these 72 villages were left out? It's because of difficult terrain. So, I mean, it was very difficult to reach those places. Maybe these are hilly areas. Maybe these are areas that have some kind of, political or socio-political problems, so on and so forth. But what happened eventually after 2016 is that gradually these were connected to solar grids. Right? So, you couldn't potentially put in access through the standard or traditional means of providing electricity access, but, solar grids were something that were supplemented. So for this part of the analysis, we switch our data set. So we move to the ACER data set, which gives us data from 2007 to 2016. So we have been working on this paper for a while. So we know that ACER has released 2018 and perhaps also 2020 now. So we maybe have to go back and kind of update this analysis a little bit. But the reason we actually use ACER data here is because IHDS, which we were using for the rest of the analysis, is not available post 2012. The 2018 of IHDS is not yet released. So we had to go for, and this program was launched in 2012. So if we have to do a before after kind of analysis, we needed data post 2012. So that's why we chose ACER. Okay, so ACER, again, those of you who are familiar would know it's a repeated cross section. It's not exactly a panel. It's not the same households that are interviewed every year, right? It's a different set of households. Some of them might be common, right? But we just pick out the West Bengal rural only sample of 5 to 16-year-olds, and ACER does provide standardized test scores again. So to give you a map of West Bengal, so the orange districts are the ones that were selected to be under the program of Shabar Ghare Alo, and the yellow districts are the ones that were left out. So these are the ones that were not under the ambit of this SGA program. So we're going to do a standard difference in difference kind of estimation. So what we're going to do, we're going to compare the orange to the yellow, right? And we're going to compare before and after 2012. The idea being that this double difference estimation strategy sort of gives you the effect of this universal electrification drive and find the impact of this on test scores to figure out whether you have consistent results with the rest of the paper or not. In those regressions, we are also including district fixed effects, a host of demographic controls like child age, gender, mother age, mother education, family size, whatever is available in ACER actually. So ACER is not as comprehensive as the IHDS, but whatever we could map in terms of similar levels of outcomes and controls, we've tried to include those. Okay, so what are the estimates using this difference in difference method? You see that the effect on reading score, again, is positive. It's on math score is also positive. We are not using writing score because it's not consistent in ACER. So some years they measure, some years they don't. And in different years, they have different techniques of measuring ACER, writing ability. So it's not very comparable for that matter. But again, you can see very similar estimates to the rest of our paper. In terms of size, these are smaller. But remember, these are reduced form estimates. So those were structural estimates that we were able to give you because we were using IV and all of that. So these are reduced form estimates. So again, if you have a small level of take up or something, then potentially you can expect that this might still blow up in terms of the numbers. All right, and we do a host of robustness checks for the entire paper to kind of make sure that the estimates are not sensitive to other things that are happening. Again, if you're interested in seeing some of these, I'll be very happy to show you. But right now, I'll just show you one or two of my favorites, right? So let me show you my favorites. And then if you have some other favorites, I'll be happy to talk about those. So what I do here is I'll show you this ordinality one. So because you know the test scores range from 0 to 4, you might be wondering that is it at some particular level that the effect is there, but not necessarily in intermediate levels. But you can see fairly consistent effects. So if you look at just 1 or less than 1, and versus above 2 below 2, above 3 below 3, it doesn't really matter. Whether you use the index of 0 to 4, whether you use standardized tests or you use these ordinal variables, it doesn't really matter. The effect sizes seem to be very, very similar. The other one is in terms of these intensive margin effects. So this is something that I also find to be pretty fascinating. So here we have broken down the access to electricity into not a dummy variable. So it's no longer yes or no. Now we actually look at how many hours of electricity you have access or not. So this is 0 to 6, this is 6 to 12, this is 12 to 15, 12 to 18, I believe, and this is 18 to 24. So you can see there seems to be an increasing trend in the test scores. So the more hours of electricity you have access to, potentially test scores are higher. I don't know what's happening here with math scores. So this is just a dip, but otherwise it's fairly increasing. Again, very consistent for writing as well. So then the general message that I get from this graph is that more hours of electricity seem to be, leading to higher test scores in general. The final graph I will show you is actually about this test of randomization. So what we do here is, instead of actually using whether the household has electricity or not, that dummy variable, we just randomly assign households 1 and 0. It's not based on whether you have access or not. So we just pick the entire sample and randomly assign households as 1 or 0, irrespective of whether they have electricity or not, and then run our regression. So this is basically a fake treatment. So it's a simulated regression, and we run these simulations 1,000 times. And what we're doing here is plotting those 1,000, the distribution of those 1,000 estimates. And you can see that this distribution of these 1,000 estimates is centered around 0 and is very far off from the actual point estimates that we had. So this suggests that the original exercise was actually meaningful. It's not just picking up some random effect, because when you are using some random effect, the strategy gives you 0 results, mostly null results, right? So that gives us some confidence in overall our identification strategy. So I think that's pretty much all I had to talk about. If you have questions or comments, and this is very much work in progress, I'd be very happy to talk about some of these. Thank you.
Thanks, Shobdeep. There is a question in the chat box. If you would like to see that.
So let me see. So can I stop sharing the screen now, maybe?
Yeah. In case you want to come back to it, maybe you can just.
Right. So I'll just stop share for now so that I can see everybody. Yeah, that's better. Household level panel. Why don't you use village year fixed effects? Okay, village year fixed effects. I think we could potentially. There's nothing stopping us from using village year fixed effects. The only thing is that it might kill off some of the variation, right? Because if you're putting in village year fixed effects as well, then what are we identifying of actually? So we are not being able to identify any changes in access to electricity. So that is perhaps the concern that we had and why we did not use village year fixed effects. Night lights as an instrument rather than village electricity availability. Yeah, I think that is a very interesting idea. We could potentially look at night lights. I'm not exactly sure whether we could map it to the IHDS, but I'm sure some papers might have worked on it. I'm not very familiar with it, but a lot of papers are actually working with the night lights data, so I should go back and look at that. So thank you for that suggestion.
So, okay. So in case you have any other questions, feel free to ask it directly, or like you said, you can type it as well. So before that, I just have 2-3 quick comments or questions.
Sure.
So first, when you find that in your mechanism in the IHDS, when you show that it is through the effect of increased time spent on studying.
Yeah.
So I was just wondering that if you could find any differences by gender there, because there's this whole host of literature on time use of girls versus boys, and this 8 to 10 age group is also a very crucial age group. And so there's this whole literature talking about household level responsibilities on girls. So I was wondering that
right. That could be very interesting. I think in an earlier version, I might have looked at it, but I forget why I chucked it out of this version, but maybe I should go back and check it. But that's a very interesting suggestion.
And second, another aspect that I was just wondering was this access to electricity that you talk about. And when you do this propensity score matching on observables, so what kind of observables are there in the data that you can divide the groups into? Because typically in Indian situation, I would imagine that within a village, the households which are more connected and
Right,
who
right.
have better networks, they would be the ones who would get the electrified first. So is it possible to check that out in the data set, or how do you use that? Um, so
So
that,
I'm just resharing one more time. I think I may have something on that. So let me quickly see if I have that.
okay.
Yeah, so in this one, what we are doing is pretty much what we're talking about. So we are including assets owned by the household in terms of an index. We also include social network, like, whether you have doctors, teachers, government employees, and also how connected you are, those sorts of things. But it does not change the estimates for that.
Right, right.
So perhaps, but yeah, we totally appreciate what you're saying. So that's the reason we actually did this.
And another quick comment that a thought that came to my mind when I was going through your paper, and as well as when I heard your presentation today, is, for example, in a context, in a setting in Bihar, it is very common to just get the connection, like without having a proper meter.
Right.
So
Right.
how do you use, I mean, that I would assume is also common in other rural areas. So what do you do with that?
Yeah, in fact,
sort of thing?
that's I mean, that's a point that's totally well taken, and I really don't know how we could account for that, because
But I
there's
think,
some of my work also which I have done otherwise, where I show that there is elite capture in access to electricity. Like, somebody and you have access to electricity, you're more likely to have access to electricity, right? And other concern, and someone is also asking that in the chat box, I believe, like extent of power cut, and whether you're stealing or hooking or doing these kind of things. It's very difficult because you'll not have, it's not observable. So I really don't know how we could account that for, but maybe include that politically connected dummy, or some kind of elite capture dummy, to see if that changes the results. Could be something.
Possibly the village level
right.
Instrument would also help, that you can only have access when your village has
yes. So I mean, we know that empirically establishing causality for this particular story is very, very difficult. That is why we thought that, okay, why not do 3 or 4 techniques and see if the results hold up? At least then maybe people are convinced a little bit. So, but yeah, I mean, we have to think about that as well. Particularly in the Indian context, it's very, very relevant.
Yeah.
Maybe
so
before we send it out somewhere.
Yeah, so thanks again for this excellent presentation. I would just request you to go over 1 or 2 more. Have you answered all the questions in the chat box?
Let me check.
There's
okay,
one
so Shilpi is asking that should the number of available hours of electricity or extent of hours be taken into consideration? We actually take into consideration we actually take into consideration the number of hours of electricity. I didn't show you those results, but we do an intensive margin. I actually showed you the graph, so that's sort of breaking it down categorically. But we also use the continuous variable, where how many hours of electricity you have, and it does not change the result. Of course, it changes the point estimate because it's a different regression, but it does not change the basic result, that it still leads to increases in access, right? BG's question is, can you please explain how to take care of endogeneity? Well, I mean, I wish I knew. So, but we do a host of things, as I said. So we try many things. So we do the propensity score method. Sometimes people like it, sometimes people don't. So that's why we thought that let's use the 2SLS method as well. Again, there are takers and not takers for that as well. And finally, we did a quasi-experimental method, as you saw, which I think has more takers than haters, right? In some sense. So potentially you can say that, that's perhaps the cleanest strategy of all that we can think of. But the concern is we have less power because we are just focusing on one state, and you're relying on just the reduced form estimate, that is intent to treat sort of estimates. You don't know what the actual take up is, but nonetheless, we are still able to do quite a lot in terms of trying to control for endogeneity. But yeah, I totally agree if you think that it's still endogenous, and I do agree it's endogenous in some sense. But even if you think of it this as an association, it's nonetheless pretty interesting, because so far people have not been able to establish even a positive association between access to electricity and test scores. So that itself tells a story, I believe. Okay, Abhishek has another point, maybe. If you aren't using village year fixed effects, then you're ignoring potential endogenous selection. there may be village-specific trends that drive selection into treatment. Yes, but as I said, these are just 2 time points, right? So if I use a village year fixed effects, basically just using 1 and comparing to the baseline of 2005. So potentially you're killing off the variation in terms of identifying. Yeah, I would love to use village year fixed effects if I had like 10 years of data or 12 years of data, right? So then compared to one baseline, you're able to put in a lot of those fixed effects. So this is just village year fixed effect would just be another dummy because you have 2 years, right? So that's my potential concern. But I will think about it since you really wish to see the village year fixed effects. I'll go back and run it and see how the results work out. And but my sense is that it may be econometrically infeasible. But let me go and check. Do the student learning outcomes vary across different levels of schooling with regard to quality or reliability of electrification? I don't know if we are able to observe quality or reliability of electrification, except the self-reported measures of how many hours of electricity that you have. And in general, it does matter in the sense that, with increasing hours of electricity, you seem to be having better learning outcomes. So to that extent, yes. But we didn't break it up by different levels of schooling. So maybe we should do that. We should probably do a heterogeneity by number of years of schooling. But again, in the IHDS, it's difficult because we just have 8 to 11-year-olds. It's just 3 age groups, essentially. But we can do more with the SR database for sure.
So I'm a bit confused about this West Bengal. Am I audible?
Yes.
Yeah, so I just have a small question about this West Bengal case study that you take. Like when you take a state-specific case study versus the national level data set, so how do you disentangle the effect of the state-specific scheme versus other schemes that would have been there possibly?
Right. So again, the idea is not to compare the state-specific effects per se. The idea is to just talk about the general effect, that whether access to electricity is good for learning achievements or not. So our objective is just to show this. So we do not position this in our paper as a policy evaluation kind of story at all. Mm-hmm. So it's not any sort of qualitative judgment on whether the SGA was effective or not. We just found some quasi-experimental variation, and we thought we could use this potentially like an instrument. But of course, since it was only implemented in West Bengal, of course, there are many such programs implemented in other states. We could pick umpteen of those. So that doesn't really matter in that sense. But we are just focusing on West Bengal to just give you a case that, even if you use some kind of quasi-experimental variation of this sort, you find similar effects. So it seems that our story is meaningful. That's the whole idea.
Okay, right.
Okay, so Abhishek has another point, maybe another potential mechanism. Can you see the times of the parents in the IHDS? Reduction in time spent in fuel collection can be used for human capital investment, which is so we do this, but we actually do this time use only for the children, I believe. But it's a very good suggestion. So maybe we could think of time use of the parents as if now they are more focused in helping their kids do homework and maybe at least nudging them to study or just sitting quietly next to them so that they don't wander about or something like that. So yeah, that's a very interesting suggestion. So I'll try and see.
I have a question. It's regarding the 2SLS regression that you run. So it seems that your instrument is the proportion of households in village which is electrified. Is it?
Yes.
So I'm not I do not know too much about the IHDS data set, but is the IHDS data set aggregatable at the village level? I mean, can you use the sample of houses in a village and makes any aggregate at the village level? Because you are using a village level aggregate, right?
Yeah, I think the way we use the term village is sort of a misnomer, I guess. So I think we should correct that in the draft. I think what we do is we aggregate at the PSU level, which is the population sampling. So I think you do observe the IDPSU in IHDS, and that's what we use for the aggregation. So it may be within a village, it could be an overlap between 2 villages as well. So
no, but I think what Shatru is trying to ask is it representative at that level when you aggregate it, like because of sampling
No,
If
that unfortunately it is not. I think IHDS is only representative at the district level. So it's not representative at the village level for that matter,
So then,
but we can aggregate it.
yeah, so then that is what the issue is. Then the proportion of households electrified, that proportion will not be representative of the village or the PSU, right? So you're using it as an instrument, but it is not a valid instrument for if you are doing it for the village. If you are considering it, as you are saying that if village is more electrified, then there is a higher chance that a particular household is electrified. But it may be the case that in a particular village or a PSU, electrified or non-electrified households have been oversampled because this survey is not at the village level, right? It is not representative at the village level.
Yeah, that is possible, and I think the way to kind of correct that would be to use use the sample weights. So I think this is a good point that you raised. So maybe we can use the sample weights to try and maybe do a weighted average and sort of a jackknife where you remove the particular household and then look at the rest of the household and that kind of thing. So yeah, these technicalities can be done, but I don't personally think it's going to change the results a whole lot. And also, it is not the main strategy. It's just like a supportive strategy, right? So that's the main story.
So so I would now request Sudhanshu to give his comments on the paper, and then we move on to the policy perspective of it, which I think is equally interesting and important. So over to you, Sudhanshu.
Thank you, Asmita. I will be brief because I see a lot of discussion has already happened. So congratulations on the wonderful paper. I had an opportunity to read the paper, so I have this advantage that I have seen many part of it which has not been presented here. The paper is interesting in a sense that it tries to address an interesting question which is related to education outcome and the role of electricity, and why it is little complicated to capture role of electricity on impact of electricity, access to electricity on education outcome. It is, as many has pointed out, and you have also mentioned in the paper, that so many complications arises when you are trying to use you are trying to look at a variable which affects various aspects of we can say human being and overall human development. If we look at the role of electricity, it is immense. So it has become basic necessity, and it is widely used. Even it is widely used as an indicator of economic development. So given its impact on various dimensions, it is econometrically challenging to determine its impact on a particular variable, which is the education outcome here. But nevertheless, and your estimation strategies and the way it has developed, it has been developed in the paper is interesting, and the results are robust in a sense that it does not vary much across the methodologies. So the three key estimation strategies like fixed effect estimation, then the PSM and the 2SLS. So all these strategies has its limitations, but given that there is little variation in the estimation result, and therefore the final result stays. There are some points which you may like to discuss here. So what is in the analysis is to keep in mind that this data set belongs to the period 2004-5 and 2011-12. So while looking at, we have to keep in mind that this was the period when electrification rate was high. 100% electricity is yet to be achieved, but a major part of the country has access to electricity now. But that was the period when access to electricity was being increased over the years, and that was the period again when a lot of policy emphasis was on increasing education outcome. So be it through increased coverage of midday meal scheme, other incentives in the schools. So this event matches two particular development. One is in the development in electrification across the country, and then the emphasis on education outcome. And therefore that study gives us an opportunity to look at whether this particular variable has an impact on educational outcome or not. And yes, it shows that there is a positive impact on that. So that is one. while discussing about the mechanism of impact of electricity access on education outcome, one interesting story is being developed regarding fuel collection time, and the statistical results suggest that this is insignificant, and possibly this may be due to the changing pattern of use of cooking gas or the alternate cooking fuel, and that has led to one. And the other, you may like to respond to the fact that the increased emphasis on school enrollment, school participation by their students in itself. When students spend more time at a school, they have little time to go for fuel collection. So automatically fuel collection time goes down when they are shifted towards a school. So that might be the reason why fuel collection time is insignificant in the study. So there are variations in the studies, and one thing that you may like to respond to is it is interesting study, and the data set, as you have mentioned in the paper, that the data set has captured IHDS data set over two sample, IHDS 1 and 2. There are overlapping households. So when there are overlapping households, and this is a span of with a gap of 8 years, so I guess there's a probability of having a children in the same household who responds about the education outcome, and therefore relating it to the impact of electricity will not be that. I'm not sure that how many households will have 4 children, that so that if you visit them after 8 years, you will have a set of children which says that okay, during this period there is electrification which has contributed to my my educational attainment. So these are some points, and estimation wise I find it is interesting and the robust analysis. So you may like to continue with the discussion, and then we'll listen to the policy inputs. Thank you.
I'll just quickly respond, maybe just a few points. So first of all, thank you very much for giving quite a lot of suggestions in terms of how I could incorporate some of the discussions in explaining the results. And I think this is why it helps to present in seminars, that you always pick up very good feedback. So I think you've given us pretty interesting insights in terms of motivating some of the mediating channels. So thanks a lot for that. I'll just want to respond to your last suggestion. It was very interesting because you are right that there are overlapping households, and we sort of explored whether or not we could use this as a panel, and in some sense we are, but we cannot use household fixed effects because, as you were kind of getting at that point, the IHDS test score data is only for 8 to 11-year-olds, right? So it's highly, I mean, it's possible, but it's very unlikely that you'll have the same household which will have an 8 to 11-year-old in 2004-5 and also in 2011-12. Right. So, and also it will not be the same individual. So you'll not be able to use individual fixed effects anyway. So you'll not be able to measure the changes in learning, which is why we didn't use only the overlapping sample in that sense. But thank you very much, in general.
Thank you, Sudhanshu and Somdeep, for responding to the comments. I now invite Shri Sanjay Kumar Ji to give his comments on the presentation and to suggest what could be the potential research inputs that you think would be useful in policy making in the current context based on what you've heard today. So over to you, Sanjay.
Thank you, Ashmita ji, and my congratulations to Dr. Shomadip Chatterjee for making this presentation. Let me just begin. I mean, it almost sounds like a truism that we always say that the per capita consumption of electricity is an indicator of your development. And your development would imply a lot of things, including educational outcomes. There used to be a story earlier that the children's eyes in the villages would close with the dawning of the sun. And the moment you have electricity, it suddenly gives you a fair number of hours to be able to do many things. So that is one. Let me begin with an anecdotal evidence. In the late 90s, large parts of Bihar did not have electricity. So a lot of people actually used to go to the railway stations where you could be absolutely sure of the fact that there would be electricity. And out of this came the great study circle which formed at Sasaram, which is the district headquarters of Rohtas. So a large number of children of various age groups, but primarily people who are actually writing competitive exams, they would go to the railway station and make a study circle at the platform, at the railway platform. And this over the years has got institutionalized. I don't know if any academician has actually gone and studied it, but if you actually go to Sasaram and you find out the number of people who may have got jobs, chances are very high that they may have been part of the study circle, which actually was the study circle of the railway station. And it all started because of electricity. So I think there's absolutely ample reason to believe that if the availability of electricity goes up, then definitely learning outcomes should improve. I was a little intrigued by Dr. Chatterjee's presentation because you divided it into two parts, Dr. Chatterjee. You said that, okay, one is the electrification of the schools and the other one is the electrification of the households. And if I remember correctly, you mentioned that perhaps there is not much of a positive correlation for learning outcomes when you talk about electrification of the schools. But at the household, you do find that there is a positive impact. Learning outcome, it depends on so many externalities. And availability of electricity is also one of the main part of it. And I think in Bihar, we are pretty happy about the Bihar story in the last 5 to 6 years, that the availability of electricity in urban and rural areas in Bihar has dramatically improved over the last 6 years. In fact, if you look at the figures today, almost 99% of houses in rural and urban Bihar have an electric connection. But then again, having a connection and using it, those are some aspects which the academicians may like to look at. I have 2-3 just observations. I think Ashmita, right in the beginning, she mentioned that there has to be some kind of a, what is the gender outcome of availability of the electricity? I think Sudhanshu was also mentioning that, if there is electricity at home, then the need to go and get fuel goes down. But if in our system, who goes to get fuel? It's primarily the girls who go out and do it. The boys somehow are prevented. They don't do it, or to a very large extent, they are not expected to do it. So I think the gender aspect of this particular thing will need to be looked into. I would particularly be interested in knowing as to how does it impact, if you look at people from age groups. If you look at the new education policy, it talks about something which we have known all the time, that the most important part of growing up is when you are about, in the formative stage. You are 3 years onwards. And if the foundational literacy, what they are talking about, foundational literacy and numeracy, it begins at the age of 3 and it goes up till the age of maybe 6 or 7. And if you have missed this particular bus, then maybe learning outcomes based on this in latter part of your life also may not be actually that good. So we would actually be quite interested if a certain amount of how does the learning outcome change when when compared to the different age groups we are looking at. Government would be interested from a policy point of view that if I'm going to target something, how do I target it? Do I see targeting of poor houses, but then electricity is available there? Can I do something, for instance, that electricity may be available, but you may not have the money to use it? So can the government target some amount of money to the poor households which have taken electrical connection with a view to improve or to see an improved learning outcome? So these are some of the kind of things I would be interested in. But I do understand, and I feel that it's a very complex thing. I mean, outcomes in our society depends on so many variables. You put electricity in a house where the parents are educated, the outcomes will be different. If the parents are not educated, and even if there's an electrical connection, perhaps the learning output may not be that adequate. So there are several things which we would actually expect professors like Dr. Somadip Chatterjee to actually look at it and maybe do a study and suggest to us as to how things can be done. And if there is a good study, then perhaps based on that, we can somehow work out some kind of targeting of some kind of help to these households. I worked in the health before coming to education. And in fact, we started mass deworming exercise in the state in the year 2010-11. And that was also with a view that it does bring about a great improvement in learning outcomes. Because the moment you get dewormed, your cognitive functions become better. And if your cognitive functions, your intellect become better, then somehow your learning outcomes also get adequately. But then assigning a number to it always becomes very difficult. So I think overall it was a great listening to you, Dr. Chatterjee. And I think we're all part of continuing education. So if based on the kind of discussions we've had today, if you can come back to us with a little more study, that how do I actually, with the availability of electricity, how do I look at poor households which have children from 3 to 6 years of age? And if you can suggest something, then maybe to ensure that there is a consumption of electricity in those households, we can target some kind of a system by which we can see that if some amount of money go to these houses, the learning outcomes become better. These are some of the random thoughts which come to my mind, but it has been a pleasure listening to you. And I would want to thank Ashmita for inviting me to be there for this particular webinar. Thank you so much.
Thank you, Sanjay ji. It's always a pleasure having you. And I'm so happy that you took out your valuable time to listen to the presentation and give your comments. So, and one thing I think, like while I was thinking about this paper, and just now when Sanjay ji even mentioned this out, that with COVID happening right now, one of the grave cause of concerns is dropout rates. And maybe like there is a lot of discussion and talk about this fact that many of the development achievements in education that we have made in the last 50 years, we might be pushed back by about 50 years because like you were saying, just this age group of children, 3 to 5, those who would be in school otherwise, they are not possibly now able to go to school. And with lack of electricity or smartphones, even if you have a smartphone, if you do not have a regular connection, it's very hard to attend school. So these kids possibly would never be. So anyway, we do know that earlier, like Sudhanshu also mentioned, that the government had many schemes which force at least parents to send their kids to schools at least till primary level. And we saw a lot of dropout after that because of other labor market considerations. But now, possibly with COVID coming, this lack of access to electricity and other resources becomes a very, very important factor of determining dropouts. And possibly that would have a very, very long-term effects of differences across families or across households who have access to electricity and who don't. And I think your paper can be an important study to point this thing out, that we do need some very immediate action in order to prevent dropouts due to lack of electricity. So thanks, Sanjay ji, again. And since we have a little bit more time left, I would just, in case if anyone has any questions, I would request them to feel free to ask them. Otherwise, I would request Shri Dilip Sinha, who is he still around or has he left the meeting? I can't. I just thought of asking him to give his comments on the talk, but I think he might have left. So, yeah. So, would anyone like to comment or give or has any other questions for Somdeep?
I mean, I'll just make a point. In fact, with COVID there, my school's being shut, and this is the second 0 year we are looking at, and we are very worried. And we were not quite sure for how long we are going to deal with this virus. And a lot of people also say that perhaps we may learn to live with the virus because it may be there for a year or two or maybe 3 years. God knows what is going to happen. So the alternate schooling system will have to be looked into. And the alternate schooling system in this particular time is going to be giving as much impetus to digitization of education as possible at the higher level, but also at the primary level, because there is just no other way out. And if that is going to happen, then I guess the role of electricity is going to improve, is going to matter even much more. In fact, we have taken a decision that we are going to electrify all our 80,000 schools. We have about 80,000 schools if I include all the high schools. So a large number of them which are in the urban areas and in the semi-urban areas that are electrified, but a large number of primary schools which are actually there in the rural areas do not have an electric connection. So we need to do that, because if you're going to run a smart class, if you're going to run a virtual classroom, you require uninterrupted electric supply. So I think in due course of time, availability of electricity, even in the schools, is going to matter much more. And it is going to occupy people like us who are part of the education system for a long time. So this is just one comment.
Yeah, sure. So, Somdeep, would you like to make your concluding comments?
Yeah, again, first of all, I'd like to thank Sanjay ji, for all the great comments that you've given. I mean, coming from a senior officer like you, it's really pretty encouraging. And it's always nice to know that, policymakers are very interested in dialogue with academics and, the way you are, planning forward. That's really exciting. And that's exactly the things that we want for the development of our country further. The other thing is, again, I totally echo your sentiments when you say that, it's not just enough whether or not you're providing electricity to a household, but it matters whether the parents are educated or not. And that is essentially the idea of, complementarity of inputs. So for instance, and this is in the context of Uttar Pradesh, so like from Lucknow, it's like 70, 80 kilometers. There's this district, Sitapur, where I had done a field survey in about 50 schools. The main reason, why students are not learning a lot, and when we interact with those kids and we kind of spoke to them, asked them what's going on, the sense that we get is they don't seem to enjoy class, right? So I think one of the things that is there in the national new education policy as well is to make teaching and the pedagogy much more interesting, right? So the way it is being taught, students are really not very excited about the rote learning and those concepts that are regularly told, or maybe sometimes there's one teacher and there are 3 classes that are going on, right? So these are the sort of things that they don't really learn. I think with digitization, with introduction of virtual classes, with use of more technology, the other new thing that we might see in the next 5 years or over the next decade is innovation in the way things are taught, innovation in the delivery of the content. And maybe that can actually lead to increased learning, or in terms of retention capability of the kids as well, much better. So sometimes what happens is when I see a visual in front of me, I seem to remember that more than when something is just being told to me, right? Similarly, in terms of social behavior as well, it has been seen, and there are some papers that have actually talked about it in academics as well, that when you tell a kid that, you should go and sanitize your hands or wash your hands at home, that seems to have lesser impact than the fact when they're actually being asked to do it and being demonstrated, that you actually make them wash their hands, or you see some kind of cartoon or some kind of video where you see that they are washing their hands and there are some benefits and there's some story that is coming out of it. So I think the next decade is all going to be about pedagogy, pedagogical innovation, and the way things are taught. And maybe post-pandemic, once it recedes, hopefully, things would become much better and we'd be embracing a lot of these changes. And then for us researchers, it would be even more interesting to do a lot more studies to try and see which worked and which do not, right? So, and thank you very much. I think overall this interaction was really fascinating. And it's not like the usual academic seminars, which is why I really enjoyed it even more.
Thanks, Sondeep, but I have my grave doubts of introducing more cartoons to kids. Like that would have other spillover effects on health and other aspects possibly. So thanks a lot everyone for joining in today. It was really wonderful too. And we do look forward to more such interactions. And I really hope that together we could formulate something which is useful for both sides. So thanks a lot for coming, everyone. Look forward to seeing you. All right, so I'll just end the meeting now. Thanks.
Thank you, sir.
Dr. Mishra, it is good to see you.
Thank you, sir. Thank you, sir. Basically, it is not after you, nothing to speak, but the education and health are very close departments, and also the home and school. So at times, the home is our first school, but it is a fact that a school becomes a home after certain age. So whatever I saw that 90% of the, in spite of the 90% of enrollment, they're saying that the less than 50% have the basic reading and writing ability. So in the era of post-COVID, I hope that the more studies will come, how to have a better e-library. It will be always difficult to have a library usually library had to be in our days. So even in the hospitals and in the schools, from the primary school to the post-graduation school, we can have e-library, and for that electricity is a must thing in the school. And rightly you have pointed that the outcome has many variables. It's a complex phenomenon. So that much, it was a very much a learning for me as a TV program. It's not my stuff, but it was a nice thing. Thank you, sir.
Thank you, Dr. Mishra. आपको अच्छा लगा और आप अपना ख्याल रखें. बंद करो.
Thank you, sir.